Today's topic, solving ratios using a bar model. And we're going to take a quick look at a basis for this lesson, one of which comes from the Common Core Standards for Math Practice, making sense of problems and persevere in solving them. And remember, this is a student outcome. This is what we want the students to be able to do once they have completed the lesson. A second basis for this lesson comes from the 10 Principles of Thinking Math, balance conceptual and procedural learning. So this is what we approach the lesson with, this planning mindset. And a third basis comes from the NCTM Mathematics Teaching Practices, implement tasks that promote reasoning and problem solving. So this is what's going to be going on during instruction. We want those tasks to be tasks that, again, don't just promote memorization, but promote an understanding of concepts. And let's begin by looking at a simple ratio. In this ratio, the number of red chips is 2 to the number of yellow chips, which is 3. Okay, so there's our base relationship of how the numbers work together. And one of the things I always talk about with kids is that in a ratio, when we see a ratio like this, we're looking at two numbers, 2 to 3, but there are 3 relationships that we need to consider. And the 3 relationships that we need to consider, the number of red chips, which is 2, the number of yellow chips, which is 3, but we also want to look at the total, which in this case is 5. And we're always going to get that total by adding the 2 relationships together. So we have 3 relationships that we're going to consider as we look at this ratio. And since we're going to look at the relationship as a bar model and not with the specific manipulatives that we have out, let's go ahead and do that. Okay, so I'm going to draw my bars. And we can see now that we have red, yellow, and the total would come from adding the red and the yellow together. And that would give us our total. So now, what if we were to ask the students how many red chips there would be if there were 12 yellow chips? How might they solve this type of a problem? And again, we don't just want to jump in and give them the answer. We want them to come up with a strategy and see how that relationship works with the boxes, with the numbers to one another, whatever, however they want to view it, and have that mathematical discussion. So one of the understandings that we want students to have as they work with this type of a model is that each of these boxes represents an equal group. So before we started with 1 red here, 1 red here, 2 red total, 1 yellow, 1 yellow, 1 yellow, 3 yellow total. So one of the connections we want them to make is that idea of equal groups, so that if they know that there are 12 yellow, then that's going to be 3 groups, and dividing 12 evenly into 3 groups puts 4 in each group. So as we pose the question, how many red chips do we have if we have 12 yellow chips, they're just going to look at that and say, okay, wait a minute, I've got a connection here. If there is 4 in each one of the bottom boxes, there are 4 in each one of the top boxes, and therefore if there are 12 yellows, there are 8 red. But we can also make that third connection for the students at this point, or help them to understand it and come to it, and that is, well, if there are 12 yellow, what if we ask the question, how many total chips are there in the group? Okay, and again, this is where they have to come and say, okay, wait a minute, I can figure out the number of red, I can figure out the number of yellow. Well, if I look at the whole picture, then I'll know the number total. So the number total has to be 5 groups of 4. The total is equal to 20 chips. So let's take a quick look at another problem, starting from scratch, not using the chips this time, and not bringing in cars and trucks and parking them on the paper. There are 49 vehicles in the parking lot. The ratio of cars to trucks is 3 to 4. How many trucks are in the lot? So again, we want to approach this from a bar model frame of mind. And so we start out by drawing our ratio, our relationship. And the relationship is that for every 1, 2, 3 cars, there are 1, 2, 3, 4 trucks. And again, we have to look at that hidden number, and that is going to be the total. And in this case, we are given the total. We're not given the number of cars. We're not given the number of trucks. We are given the total, and we know that that total is equal to 49. So we have to look at this and say, what relationship am I going to use that 49? How am I going to use that 49 to help me determine what it is I want to know? And we know that there's a relationship here of 7 pieces to the total. 7 goes into 49 7 times, so each piece, since they're equal pieces, would be 7. Okay, since each piece is 7, and there are 4 pieces that are trucks, I know that there are 28 trucks, and I also know that there are 21 cars in this particular relationship. Just to provide a little extension on this activity, even if we have ratios that involve more than 2, we can still use this method to solve. So let's take an example here where we have people going to the movies, and we have 4 people going to see the movie Star Wars. So I'm going to use that first bar, and it's going to represent Star Wars, 4 groups for Star Wars. And for Superman, for every 4 that went to Star Wars, there were 3 that went to see Superman, and for every 3 that went to see Superman, and for every 4 that went to see Star Wars, there are 2 who went to see Batman. Okay, now, we still have our total, only this time our total is made up of 3 pieces. So 4 plus 3 is 7, plus 2 is 9. So our relationship to the total is going to be 9 groups. So now, no matter which one you're given, let's say you're given how many went to Star Wars. Okay, so you're going to say, well, I want to pick a number that's going to be a multiple of 4 because it's 4 groups. So let's say 16 people went to Star Wars. That would put 4 in each group. So I could solve how many went to see Superman, which would be 12. How many went to see Batman, which would be 8. Or how many total people went to the movies that weekend, if there was a... So as an extension to this activity, I could look at a 3-component ratio. So for every 4 people who went to see Star Wars, 3 people went to see Superman, and 2 went to see Batman. Okay, so I draw my bar, Star Wars, 4 parts, Superman, 3 parts, Batman, 2 parts, and again, keeping in mind my total, that would be there are 9 groups in the total. So if I say 16 people went to see Star Wars, I understand that that puts 4 in each one of these. 16 divided by 4. That puts 4 in each one of these, so 12 people would have gone to see Superman. Puts 4 in each one of these, so 8 people would have gone to see Batman. And the total would be 9 times 4, so 36 total people would have gone to the movies that weekend if 16 of them enjoyed Star Wars. But I could also solve this by being given the total. Now I want that total to be a factor of a multiple of 9. So let's say 81 total people went to the movies. Okay, how many people went to see Batman? Well, there are 9 total groups. 81 divided by 9 is 9, so that would put 9 in each box. 18 went to see Batman, 27 Superman, 36 Star Wars. Okay, so that's a basis for using the bar model. One of the things we need to keep in mind as we're using this process is that our goal is not just to get them to solve the problems using a bar model, but our goal is to develop that thinking, that mathematical connection or understanding of what a ratio is. So we begin with this conceptual process, okay, of a bar model. So here's a ratio of 2 to 3, okay, and remember our hidden number, okay, so there's 5 in the total. So let's say that we are given a problem such as there are 2 reds to 3 yellow. Okay, so we've got our 2 to 3 relationship here. And there are 15 total yellow. Okay, so 15 divided into 3 equal groups would put 5 in each group. That puts 5 here, and it puts 25 as our total here. But when we switch over to the procedural side, okay, where we're getting away from the visuals and looking more at an algorithmic approach, okay, so we have 2 to 3, okay, and we know there are, and let's go ahead and label them. So we said it was 2 red to 3 yellow, so 2 red to 3 yellow, and we said there were 15 total. So what they're going to see here is, okay, I need to make an equivalent ratio, so they can hopefully draw back to their understanding of equivalent fractions. So 3 times 5 is what would give me 15. So 2 times 5 is what would give me 10. So if there are 15 yellow, there are 10 red, and I also can, just by either adding these up or multiplying by 5, 5 times 5 is 25, giving me the total, and I verify that by looking at the number of reds, the number of yellows, and in this case I still get a total of 25. So that's using a bar model to promote understanding of ratios.